humans are expensive, and so people are often trying to find ways that we can kind of reduce the humans a little bit. Now, I think there's two different areas where you see kind of humans are able to be replaced.
Today's conversation is with Rajiv Shah. Rajiv is one of the top voices in the domain of LLM, and specifically when it comes to LLM evaluation. Professor Rajiv has taught in the University of Illinois and has more than 10 years experience in data science. I should also mention that he has more than 40 major publications in the domain of LLM and traditional machine learning. He is an ML engineer in Hugging Face, helping enterprise to realize the value of AI. Rajiv, thank you so much for being here.
Oh, thank you for having me on. I'm excited to talk to you guys.
Absolutely. So let's go ahead with and start with the most centric question for this talk, which is why LLM evaluation? So if you can walk us through the story of this rising phenomena of LLM evaluation as, I would say, sub-industry or maybe sub-field of the LLM domain as well. What brought us here into all what we have seen in 2023?
Yeah, and I'll give a little bit of a story to it. And I think part of this is just how the AI space has grown. And I saw this earlier with machine learning and big data, is we get a lot of advances in the field. Researchers talk about, hey, look at these improvements that they've found. And people start focusing on models and algorithms. And hey, if I use this specific algorithm or use this specific model, look at the amazing result that I get. And I think what people often lose track of when they start doing that is at the end of the day, they're going to have to apply those models or algorithms to their specific problem. And the only way they know if that's actually helping out versus kind of traditional other approaches they've used is if they take the time to do proper evaluation. So evaluation can often be neglected, right? It's not as kind of interesting or sexy as kind of the latest algorithm or model. But at the end of the day, from my experience working inside enterprises, from building out publications, writing out, building projects out, I know having that evaluation pipeline, making sure you've set up good methods like that is really important to be able to create something valuable.
And how it's differ from the traditional machine learning evaluation?
Yeah. So in traditional machine learning, we've done evaluation for a long time. So if you think about using something like a confusion matrix, we have lots of different metrics we can pull from that, right? Precision, recall, true positives, all of this type of stuff. Now, what happens in traditional machine learning is we're doing what I call discriminative machine learning. All the machine learning is around predicting a certain class or a number. And so we have a very easy quantitative way to define what we want to measure. The nuance when it comes to generative is now we're asking the model to generate output. And there's a lot of diversity of outputs that can be created. And because of that, it makes it harder to kind of quantify it and put it back in the box and easily measure it. So a simple example of this is you might think about something like, I want to generate a customer support email. Well, there's many ways to write a customer support email like that. And so this becomes harder to exactly score which one is the best one like that.
That is great. Actually, I think this is drive me to my next question, which is, since we are in the beginning of the new year, like 2024, and looking back at 2023 and previous years, could you draw a mental map for us on what is the LLM evaluation methods that has been followed and adapted till 2023 in a very high level, not necessarily just to have like an 360 view?
So I think early on, a lot of the LLM uses mirrored traditional NLP type use cases. So we use an LLM, for example, for classification. So then we could use the exact same classification metrics around that. So I think for many things like that, we could use traditional NLP metrics. Where we started seeing things go a little bit off is when we did things like, for example, code generation. So here, matching to, right, there's many ways you can write code to solve a problem. And this is where the folks started coming up with, hey, can we find another way to evaluate this that's just not looking at the distance between letters or words, but we need some way of almost unit testing to see if the result is right. And so we saw this evaluation of approach of functional correctness over the last year for those code projects. But what we've seen is as we've gone on, people are starting to push and use these LLMs to create this diverse outputs, to create, hey, I want to be able to build an email, an email bot or some summarization where we need this diversity, and where it gets tricky using traditional NLP metrics, and people have had to come up with newer ways of doing this.
So something like benchmarking and human evaluation and red teaming and all of those different methods, could you walk us through, like for example, benchmarking, it's heavily relied in, you have to have a database. And you have those data sets, when you create them, they are laborious. They take a lot of time to create. So could you walk us through what is the advantages of the benchmarking part, which is, there is plenty of them, like, millions of tools out there. So what's available and when to use them, and what is the limitations of them?
Yeah. And I think we could start with the gold standard often for evaluating the outputs is a human. But humans are expensive, right? They get tired. They have a set of biases. So this is where especially researchers are often looking at ways, can we find a way to automate this, right? Can we quantify this by doing this? And so a popular way to do this is, let's ask LLMs to give multiple choice answers. If we give multiple choice answers, then we can quantify that and evaluate it kind of in a very programmatic fashion. And one of the things we've seen is the development of lots of different benchmarks that often focus on very short answers or multiple choice questions. And this allows people to kind of quickly evaluate. If you have 10 different LLMs to compare, it allows them to quickly compare 10 different LLMs, see which one is better. Now, of course, we're limiting ourselves now because now we're focusing on these multiple choice tests that everybody knows about, that everybody knows that they're being measured against, which might not reflect how we actually might want to use the model in the real world. But these benchmarks are a quick way for people to assess how well they do, how well models compare against each other. And we've seen a plethora of these benchmarks. I think the Hugging Face Open LLM Leaderboard is probably one of the most famous ones that measures, I think it's something on the order of about 2,000 different models at this point across about 6 different benchmark metrics to help you understand how these models rank compared to each other.
So those benchmark, I know that they can be applied to the foundational models. But when it comes to the domain and use case specific, what is the best practice here? Like, if I am doing a very specific fine tuning or maybe implementing any RAG pipeline in my data, how that type of evaluation differ from these generalized benchmark? And what is your suggestion in this case?
And this is where I'm not going to give an answer that people like, because the answer to do this evaluation is often it takes a bunch of work. It's very easy to cut and paste somebody else's evaluation benchmark, but that's not going to fit kind of your particular needs. And this is where it's just like traditional machine learning. You had to spend time people labeling data, coming up with benchmarks like that. If you're doing something that's a little bit different, well, you're going to have your experts, the subject matter people, sit down and build an evaluation data set, an evaluation test scheme for that. Now, we can talk a little bit about how we can use things like LLMs to help automate that. But at the end of the day, if you're doing a custom problem, you're going to need a custom evaluation, and it's going to take some work often to do that. And that needs to be part of the planning process for when you're solving these problems.
That is great. And this has led me actually to the human part of it. There was a lot of hype, at least in the last 5-6 months of 2023, that human may be gonna be replaced as from the loop. Like they're trying at least to reduce the amount of human engagement within those. So how do you read this role of human, and specifically when it comes to domain experts and all of that? Are we gonna replace them at any given moment?
Yeah, so humans are expensive, and so people are often trying to find ways that we can kind of reduce the humans a little bit. Now, I think there's two different areas where you see kind of humans are able to be replaced. One is we see using LLMs as a judge, as a model that helps evaluate it, and that works if the model is about as good as a human for a particular task. So if you're asking a model to, analyze, for example, everyday sentiment, a model's going to do a great job at that. Better to probably easier to use a model than to use a human for doing it. But on the other hand, if you're asking a model to do kind of, I want the sentiment of, is the stock going to go up or down in this particular sector? Well, the model might not know as much. Your human experts that are your experts on that might do a better job of that. So that's one area where we can find tasks that are as good as humans that will see the replacement. I think the other excitement you've seen in the last 5 or 6 months is one of the parts of training these models is, especially models like LLMs, we want to make them helpful and we want to keep them from inflicting harm. So we want to build harmless models. So we don't want models, for example, that are racist. So there's a substantial part of training an LLM like a ChatGPT that goes into how can we transfer like these human preferences? Because we understand when we read text, right? When we read a Stack Overflow, which comments are most helpful, which ones aren't helpful. Like humans can do that very quickly, but we want to translate that into that LLM. And so this is where we've seen a lot of research in how can we effectively find ways to reduce the amount of human involvement in the training of that. And so this is where, for example, my colleagues at Hugging Face have been working on methods like direct policy optimization, DPO, to help find ways to kind of reduce the amount of human labor that we need for doing that type of thing. But, those are both two different things. One is that the general, we need to solve our everyday problem and how much we need humans for it. And the other is this problem, this very specific problem around helpfulness and harmfulness and how we can get those preferences into a model like that.
I know that's not going to be a happy news for so many companies. That specifically that those companies that they provide human in the service as a service, human in the loop. So what are the future of those annotation companies that they're not only providing a platform, but providing the data as a service? It's either by collecting synthetic data or by just annotating and evaluating. Like from your own perspective, what do you think are they going to have like some futures within like the next 5 years, I would say?
Yeah. And, a lot of these places, well, for example, like that sentiment example that I used, might have humans label some sentiment like that. But I think one of the things we've already seen with some of these areas where you're using cheap labeling to do that, and the humans aren't getting paid very much, they might want to cheat too. And so we see often that the human laborers might be, you might be thinking you're getting human input, but they might actually be using a model to get that to make their life easier. So it becomes very confusing, where the human and the model kind of inputs are coming into data. And this is where we've hit this point of contamination, and so to speak, between the model and the synthetic data, because these models can provide often, very similar to human input, or outputs like that for that. So I think it's a very tough task when we get to the cheapest modeling pieces, the things that take the least amount of thought for humans, where we have models that can create similar outputs. It gets very tough. Now, on the other hand, if you're still having humans do tasks that models aren't very good at or nuanced, well, yes, we still need humans to be able to kind of do that, like that.
Okay, that is absolutely great. And lead me to, I know that you worked with the Snorkel AI. Me, myself, I have worked with some of my project, including weak supervision for labelings. How do you see those type, like plus, like if you include the LLM part of it as well, how do you see those type of platform helping the LLM evaluation specifically?
Yeah, so I think weak supervision is just another tool in that toolkit of when you don't have lots of data. And so I think now what's happened is before, when we didn't have lots of data, that weak supervision was a really important tool to go to kind of get experts to kind of create those labeling functions, those rules to help us kind of take advantage of lots of unlabeled data. Nowadays, what's happened is for many of those use cases that were simpler, we can now use the LLMs to help annotate it, the model as a judge, where I can ask my model to say, hey, instead of asking the human to label the sentiment, can the model label the sentiment? So it takes away a lot of the simpler kind of cases out of weak supervision. But I still think there are plenty of use cases where you have experts, for example, where their time is very costly to have them human label things, where the model's not going to be able to do it. So you can think about here like looking at medical x-rays and doing medical diagnosis of vision pieces. Like your experts aren't going to be able to label 10,000, 100,000 of those. And so if we can use some component of weak supervision like that to assist us and take advantage of all the other unlabeled data, there's still a good use for that as well. So I think this is one where, as we kind of build these different tools in our toolbox, some of these tools are going to grow more in importance, but I think it's important to realize that there are still lots of tools and when it makes sense to use each one of these types of things.
That is great. Let me shift gears here and talk about the multi-models, which is the buzzword, another buzzword for this
Yeah.
year. So the future is going to be most likely a lot of company pushing toward multi-modality type of foundational models. For those models, what degree of complexity it will add into the evaluation process?
So I think multimodal is something, and I was pushing multimodal machine learning models like 4 or 5 years ago, like that. Like we've had this for a while, this ability to combine different modalities together and kind of use different modalities to solve a particular problem. I think some of the challenges are finding use cases that we need that for. It's often kind of a very cool thing to kind of demo, right? I can write something on a napkin and then and have it pull up my web page code is one of the things OpenAI when they first demoed this. But one of the things I struggle with is finding enough practical applications that are valuable inside an enterprise setting for the multimodality. So some of the common multimodal use cases we've actually had for many years is around document AI. So think about, you have a document. Yes, you can OCR and get the text, but having the structure of where the headers are, where the page number is, where the tables are located, conveys important information. So we've had those vision text models for a number of years in that, and we see, right, you see a performance gain when you combine both those modalities in that. And so most of the kind of the best document AI models nowadays use both that or are that multimodal. But I think it's going to be an exciting time. Now we can kind of fit all of these things together from a data science and machine learning perspective. It's amazing if you look at some of the work, for example, that Meta has done. I think it's the seamless model that combines like 5 or 6 different modalities together into one space and one model. So from a technical perspective, we're very good at being able to use all of these different modalities, putting them together. I think the challenge will be finding enough kind of use cases where we kind of need that multimodality.
Yeah, and the complexity here is not only from bringing all of those modality together, but also you have the multilingual part of it, and you have the multi-domain part of it. So, and this is all going to be propagating into the LLM evaluation as part of it. And plus, in the LLM evaluation, you have the task-based evaluation as well. So I heard you, kind of talking and suggesting building your own leaderboard as an internal company. Could you touch base on that with more clarity and why
Absolutely.
people need it?
So one of the things we've seen success with is as we've gotten. So let me back up. I think one of the things that's really changed in AI and ML is we've had the growth of these pre-trained models that provide people a good starting point for building models. But what we end up with is we end up with many pre-trained models, and people want to know, like, which one of these should I use? Which one is better? And so there's been a natural evolution that there wasn't 5 or 6 years ago towards having ways to compare multiple models, because the great thing is we have lots of choices now for models. And so we've seen the emergence of these leaderboards. So I mentioned the OpenLLM leaderboard for kind of the large language models, but we have leaderboards for other tasks as well, for embedding models, for audio to text models like that. And we see just a huge growth of people that just want to be able to rank all of these models on different types of criteria so you can pick the best one. And I see the same thing happening for enterprises, and I'm actually working with some of our customers now where they want to have boards, or they want to build leaderboards for their particular use cases. So on their test data sets, and then for their particular models, but they also want to be able to bring in, as new models get developed by the open source community, they want to bring those in, quickly train them and see, hey, is this something that would give me a 5% bump or a 10% bump over what I'm doing? Or are the models that we're doing, good enough, and we wait another 6 months or wait till the next open source release and see and assess then. But I see kind of a huge demand for this as we have just so many options to do that, where people want some help ranking these and knowing kind of where they stand compared to the state of the art for their particular use case.
And would you consider this as a pre-evaluation or post-evaluation?
For me, evaluation considers that whole life cycle. So
Okay.
your evaluation might change over time, where in the beginning it might be very rough, and over time you might get much more nuanced and looking at specific, many more attributes than you do at the beginning. But I think you need to do that through the entire life cycle. Like early on in the project, you need to see if it's worth the investment or time for doing this, if you're going to be able to solve that business problem at a good enough accuracy or level to make it worthwhile to even start the project.
That's a really good point. And I wanted to pick up your mind in this from a business perspective. I talk to so many different clients. I work in customizing LLMs for them. And they always hesitating when it comes to the evaluation efforts and money. So how important it is to have your LLM infused application monitored and evaluated in a regular basis, and why is it the case, and what is the justification for the ROI, like when you talk to the upper management for such a thing?
And so I think, evaluation in this aspect of what you're saying is there's both the initial training of the model as well as the ongoing monitoring. So I agree. Evaluation is sometimes a little bit hard to to explain to somebody that isn't kind of in machine learning. And I'm sure there's probably good analogies. I can't think of that right now. It's a little bit of one of these things where it's an ounce of prevention is worth a pound of cure. Or for folks that are in technology know that if you build a modular, repeatable architecture that you can use, it makes it much more agile, much more quicker, much faster to kind of iterate as well. And so often the folks on the technical side will get the value of evaluation, and you can convince them of that piece, because they know that once you have that, you get through everything else a lot quicker. And if you have changes, it's easy to do that. So there's a natural kind of gravity to people. As soon as you point out like, hey, let's build evaluation, most technical people will kind of get on board, because they realize, if this project is of that magnitude of value, that we should be doing this. The next piece you said is that evaluation doesn't stop at the first iteration of the model. Now, after you put that model into production and you start using that, you still want to do that evaluation. And this is often what we call, monitoring or observability around that piece, because the things is, in what happens in real life is that the data will change over time. Somebody will change the table names or something in the SQL, and that's going to affect your model. The world is changing. So if it's something about natural language and how people use words, right? That context is changing on a regular basis. It could be if you're doing something with discounts or coupons or excluding some people, there could be a gaming aspect of it. So the point is that you need to continually monitor, make sure your model is effective, because over time, often models will decay and lose their effectiveness a bit. And if it's not fully effective, you're not getting your full value out of it. So then it might be something that, hey, Let's take the time to retrain, figure out what's going on, and improve that.
And there is a whole different paradigm on the evaluation, which is the red teaming and the safety of it.
Yes.
Could you touch base on this and map it into what all the governments and European Union, White House, trying to impose those different policies, how those things kind of attach to the LLM evaluation part?
Yeah. Yeah, no, and there's a lot there. So I think, going back to remembering that the world is a little bit different with generative models. They can produce that wide variety of output. And what they can do is, because it's such a wide variety of output, it becomes much harder to assess the riskiness of a given model because you don't know exactly what it's going to output. There's a whole thing on determinism, but the point is that there's many different possible outputs that could happen for a given input. And so one of the things where we've seen folks do is spending time, especially models that are going to be available to general consumers or chatbot type models, attacking a model proactively to see how it might fail. And this is often called red teaming, is this type of thing. It comes from the cybersecurity world. But this is something that we have to do if we expose these models to inputs that you might not know what's going into these models. You're going to want to test all the different type of scenarios. And you can think about it like in financial models, often there's stress testing of let's figure out the extreme scenarios and see how the model performs under that. Well, that's the same thing we have to do with red teaming. Is we have to take our models, put them under these extreme circumstances, make sure we understand what they're going to do. And then, sometimes we might not push the model forward. Sometimes we might add additional guardrails around that piece like that. And I think, there's a very sensitive aspect, especially when you get to models that output language that's going to a general public. If we look at the history of what's happened in large language models and chatbots, the reason ChatGPT was so popular, I think, is because it was widely acceptable to a large group of people. There's been many generations earlier of models where hackers or people were able to come in, get the models to say all types of nasty things, and then everybody throws up their hands like, hey, we can't have a model that outputs something like this and pulls back. And ChatGPT was the most robust to these kinds of attacks. So people actually were able to kind of see through all the obvious kind of racist attacks and then be able to really grasp, oh, this is how I could use it. This is how it could be valuable and do all of that. Where often I think, some of the previous models like the Metas, Galacta, people never got the chance to really understand that piece because we were so focused and worried about what could go wrong with these models.
That is absolutely true, but they change it from an open source to a commercialized base right away. So what do you think about the move, and what is the future of those two different approach for AI? A lot of people like Meta, they are pushing toward like an open source. So how do you read the future, and what is your argument? Which one you prefer?
Yeah, I mean, in the software industry, we've had open source and proprietary both for long times, and they each have their strengths. And I think one of the things we've noticed in software and analytics is the strength of the open source. That, when we have these problems where there's a large community of people that want to solve them, that crowdsourcing of development where we can look at the bugs, find the bugs, take advantage of all the most interesting ideas and roll them together ends up being the most valuable. And this is where I've seen it in my career over the last 10 or 15 years, the growth of open source. And we see the same things in machine learning and AI where we have this. And I know it was a little dark, probably 6 or 8 months, ago when OpenAI first released its model, and there wasn't, the open source models weren't nearly at the same level. But over the last year now, we have a number of different companies that have released open source models that are, on par with something like ChatGPT 3.5. They might not be up to kind of GPT-4, but you can clearly see that the open source is capable of building very good models like that. Now, I still think there could be a room for OpenAI, for Anthropic, different business models. Maybe they can squeeze ahead and stay ahead a little bit of the open source. Maybe they'll offer other features, enterprise features, family-friendly features, right? There's lots of different things that they as a company could do that could distinguish themselves from the open source. But I think the last year has clearly showed us that open source is clearly a contender and is clearly going to be one of the most influential pieces in large language models.
And how about the open source in terms of LLM evaluation?
So when we look at LM evaluation, the great thing about LM evaluation is and maybe it's not too great actually. It's always been very open, and maybe sometimes I think it can literally be too open. But let's talk about first as a whole. There's lots of benchmarks that people are widely using that are available to anybody. You don't have to go pay to get an evaluation data set. So we've made all these things widely available like that for testing out and seeing how well a model you built compares to kind of the other state-of-the-art models. Now, one of the rubs of the downsides of this is having these evaluation data sets open is that it's possible for people to cheat. It's possible for people to look at the answers and build that into their model. And, there's some concern and there's people writing papers and tools to help detect that piece. But I mean, it comes a little bit with the openness is that people can kind of cheat that piece. I don't think it's been a huge problem so far. It's something to be concerned about on the nuance side of it. But I think at the end of the day, it's great that we have these open evaluations that companies, and lots of companies have put forth these open data sets. Even folks like Anthropic, for example, has, put out its data sets that people use to build on like that.
So if we need to build some database and data sets that we're gonna be able to fine tune our own models with, but we need that not to be commercialized because you mentioned the human cost of it. Mm-hmm. And we needed to have it as an open for community where everybody is coming in and doing their part in terms of annotation, maybe editing, maybe rating, ranking. But instead of having it in very closed environment, now you open it up for everybody else. Is there any solution out there, and if there is nothing, so what do you think of this type of approach?
Yeah, and I think there's a couple of different open approaches that have done similar things to what you said. So there was early on, and I can't remember the exact name of it. There was a group, and I think Yannick, one of the YouTubers, was the one leading this, to build an instruction data set that was entirely open, where they had thousands of people that spent time kind of annotating, creating content to create an instruction data set. And so just to give people a flavor of like what an instruction data set is, the early large language models would just they would finish a story. You would tell it once upon a time and it would finish a story. But what we want models to do is I give it a specific task and we want it to solve a task. So if I give it a question like, hey, what's the capital of California? It should be able to come up with an answer like that. So we have to teach models to think about not just completing a story, but solve problems like question answer. And so one of the first data sets was this open assistant data set that was created entirely with human volunteers that spent their time doing it. Databricks also built a similar data set using their own internal employees, the Dolly data set like that. So we have pieces like that for kind of creating some of these data sets. On the evaluation side, I think one of the best evaluation techniques has been the LM-SIS group's chatbot arena, which consists of people going and looking at the results that come back from different models and having a human decide, hey, which is the better response? And this has been held up as one of the best ways to actually evaluate all of these LLMs because, as we talked about, it's too easy to kind of game all these benchmarks, these automated benchmarks. So keeping humans in the process and using their insight to be able to judge these models is kind of at this point held up as like the highest quality score for these LLMs.
In one of your talks, you mentioned like the psychology of the human and the diversity in it when they evaluate those LLM outputs. And it was very interesting for me to see like it is so true that sometime when the LLM sounds so confident, that could influence the human decision. He just gonna go ahead and say yes. And there was another paper that they looked into the human annotation for a large group, and they found that when you explicitly tell the human this is an LLM output, they're kind of having some type of negative feedback for it. So, this type of biased things, could you touch base on the topic itself?
Yeah.
And
So, I mean, humans are often considered the gold standard, but yeah, we're full of biases. We're full of things that aren't rational that we're full of. So, things like positional bias of taking the answer on the top versus on the bottom, or if an answer is worded in a way that's very strong and firm, like we'll be like, like they're really sure, and then people will give it a slightly more authority, even though it's the incorrect answer, like that. So yes, I mean, humans have long been kind of various biases, and right, there's lots of cognitive studies that study all the different biases that people have. Like that. It's kind of like democracy is the best form of government, or the worst form of government, except all the others, right? Like human is the worst evaluator, except for when we look around all the other tools we have for doing it. So yes, I mean, I think there's many things. The good thing about human evaluation biases is it's been well studied. Machine learning folks might not be aware of all of that, but this is where psychologists, qualitative researchers have long studied, quantitative survey researchers have long studied a lot of the biases that affect when you're trying to use humans to do it. The other part that comes up is that these biases, though, also affect models. Models aren't entirely neutral. They come with their own sets of biases as well that we have to be aware of when we decide to use them to help evaluate content.
yeah, you mentioned even like the same person could be performing differently depending on what time of the day and
Yeah.
uh, how they feel and all of that. So it's totally true, and that's why I think we have like multiple round of annotation and measuring the disagreement between all of them. So it has been like a very established project. Okay, so I would have two more questions here for you. Is if you would be building an optimal evaluation tools, and this is just like some mental gymnastic type of things, what are the top element that you would be including to make it inclusive and addressing majority of the use cases?
Boy, that's a tough one. I think, the biggest thing I see for evaluation isn't necessarily some like kind of a tooling thing or like a specific process that we need to do. It's often the evaluation that we're doing isn't meeting the needs of the stakeholders. So the data scientist will look at some types of metrics and solve some type of metrics. But when you actually go and ask the people who are going to use this model in the real life, they'll be like, no, that doesn't matter. Like, this is what matters. And so I think, the biggest tool I have is just that communication with who's going to end up using this model and taking the results and applying it to their job, is making sure that your evaluation is aligned with that piece. Because often we get focused on, metrics and algorithmic ways of doing things, but we kind of, it's like we're missing the cart or missing the horse, or there's some analogy there, but we miss the entire thing because we're so focused on this one aspect versus what's actually going and how people are going to use the model. Because that should really be the starting point for thinking about how we should evaluate it, and then using all the tools you have for figuring out a good evaluation setup based on that.
That is a really good point. Okay, my last question, I would like to read your perspective in the future of the LLM evaluation, at least maybe in the near future of 2024. And again, in terms of tooling, approach, platform, open source, vice commercialized.
Yeah, I mean, already in the beginning of 2024, it's getting really messy with things like the OpenLM leaderboard because it's so easy to kind of cheat, where I think we're going to see some movement on some of these benchmarks that we're using to, can we move to benchmarks that, for example, have hidden test sets or change test sets over time to better kind of combat those models that are overfitting or cheating to that piece there. So I think we're going to see some movement towards that. We're going to see an increasing use of using these models as judges or evaluators. I see that being widespread use of that. And I think as these models get better and better for a lot of the human type tasks that we do, we're going to continue to see kind of the growth there as well. So I think those are the two biggest things: is improving benchmarks and increased use of the model as a judge.
All right, that is absolutely great. I know that you're going to be speaking in the Data Innovation Summit in 2024, maybe in April. Would you like to give us some, hints on this or?
Yeah, no. So I was invited out to speak out there. So that's out in Stockholm. So for any of the people in the Nordics that are going out there and want to make a trip out that way, I'll be speaking out there. Yeah, I'll be doing I think it's about a half-hour time slot on evaluation. So I'll be getting into all of this pieces here. I might even get into some of the other interests that I have, like for example, getting explanations for the predictions that we come out of models. But I'll make it entertaining and it'll be fun. So yes.
It's always fun talking to you. Thank you, Rajiv. Thank you so much.
Thanks for taking the time.